cross-matching tools, these kind of things. And we can, let me check the questions that we prepared. Okay, so, well, first one obvious question is, how can we do better? I know that it's a really difficult problem with many parameters, but I don't know if you have any ideas what the future will provide to us in this field.
Yes, sir. Um, we can do better in which respect? In improving in the identification,
yeah,
or helping the community?
and also how to, you know, I know this has been a running thing all this time of how make the life of the user easier, which is the balance.
I think for me, there are the tools for already doing a good job. The big problem that I see on our side is to get in contact first with the provider of the ancillary data and try to make them generating a product that we can use better. I was mentioning before, Model Flux does not represent AGN. You are able only to represent point sources, so Quasar and PSF, stars. Everything else is not well represented. We need a different approach. We need to have something that is tuned for our sources. It's not only for identifying the counterparts, it's also for determining the classification. Again, all the classification done is using parameters that were not tuned for AGN, say. So this is one of the biggest problems that we have for improvement. The tools are already there. It is the ancillary data that are not yet ready for our needs.
Mm-hmm.
Of course, I totally agree. And as for the tools are there, we perhaps could improve our examples or things like that to reach a wider community as of giving hints of how to use them best. Or manuals are there, but we see a trend of not reading manuals. And perhaps, I mean, I know that it's very much a la mode or en vogue to do Jupyter tutorials and stuff like that, Jupyter notebooks, right? So perhaps going into that direction, given the tips and hints, I mean, it's like a manual, right? But it's dedicated to a specific problem and so on. So it's also a compromise between how much can we do, but yeah.
Hi, good morning, everyone. So I think most people here don't know me, so I'm Emily. Nice to meet you. I work I have a background on Supernova, and I work on Think mostly on optical, so I'm certainly out of my depth here. But as someone who uses catalogs from other communities and look through that a lot, I think there is I think there is, especially now that we are preparing, for example, now for the arrival of very, very big data in all of the communities, the groups that are developing the tools that you find in other wavelengths that you might look for your data, they are just doing the best they can. So I think it's also important that we have like if you see something in some catalog or some tool that you see online that it's not exactly what it should be, I think all of the development teams will be more than welcome if you send an email and say, you see, this is not exactly correct, we should improve this better. And this can start a conversation that might lead to better improvements in the future, because it has been said a lot since yesterday, and I'm learning a lot on this, so I'm very happy to be here. But it has been told a lot about not reading manuals and stuff like that. And although I understand that is not a correct aptitude, I understand that it's difficult to find the time to read the manual. So ideally, what I would want is to have a friend that I completely trust in the other wavelength scenario that I can ask, hey, by the way, am I doing the correct thing here or not? So if we approach the development team with the goal of trying to help them improve their tools, I'm pretty sure that we can like start a conversation in that sense.
I understand your approach, but many of these codes are actually available in GitLab, and people are welcome to take them and develop them further and share them. So you don't need to go back to those that started the work and ask them, hey, can you go better? Yeah, you could also do it and help the others.
Okay, middle term. So there are both cases. Okay, oh yeah, please give me the feedback. Do a pull request or the I don't know. Yes, we can give feedback, but sometimes the details on the coding are not accessible to everybody. So engineers can have a expertise in one side, astronomers in another one, and we can work together. Not everybody can do 2 PhDs at once, right? I mean, so I think it is important to have a team of experts in different parts. I don't see the problem with that. And developments can be coming from both sides. So this is faster, this is more efficient, please do this like that because you're going to be super Uber. And then on the other hand, the astronomer can say, well, you know, that's very good, that's very fast, but I want this other implementation. Could you also do it? So I am willing to compromise between one and the other. So I think not everybody can have the access to the engineers. Not everybody has the lack of working in an environment where you have both working together. But if we are in that situation, I think we should work as a team to move forward in that process. And yeah, I think that that can be a way a little bit that we could improve. But again, we are a few.
There is also another way to improve, namely having the same benchmark that everybody can use for testing their code and have something secure and then say, look, using the same training sample and the same validation sample, we are getting different results. It is something that started already in the 2010 with the photometric redshift. There was a famous PATH challenge, and it is still available. Everybody can download that data set and make their own photosys. There is now a benchmark called GRASP, Chimera, for the SED fitting of AGN that people can download and test the approach in decomposing AGN and host properties for identification of counterparts with the catalog of ERAS-1 of counterparts. We are releasing our training sample and our validation sample. So there will be 24,000 secure XMM sources with secure counterparts with the properties in Legacy Survey DR10, Gaia, and Cutwise. There will be 3,500 Chandra sources with secure counterparts that can be downloaded as well. And then you can decide to modify your machinery for defining the prior. You can use your own code for the identification. You have the same validation sample, and then we are going to compare really the properties of different methods and the quality of different models.
One question about this. Do you think that machine learning and artificial intelligence can have an impact in this? We know that it has in classification, photometric redshift. I don't see how, but I don't know if you have an opinion about machine learning for cross-matching.
So what I was showing this morning, it is all machine learning done with random forest. So the additional properties analysis done with 20 features for Legacy Survey, Cutwise, and Gaia, it is all done using independently random forest and then use that probability
Yeah, that's,
multiplied with the geometry
yeah, that's for
probability.
beating
So
the-
this is
that- for
exactly
beating the prior,
yeah,
right?
that the
Exactly.
model is created via machine learning.
Mhm.
Yes. But of course, you need to create a machine learning that with
Yeah,
your
of
brain,
course.
not trust everything that machine learning proposes you. There is a question then.
I'd like to ask a slightly philosophical question about this approach that just occurs to me. I've got half an eye on Athena here. So generally, I believe with XMM and so on, what we tend to do to get when we've got our original X-ray image, to get the most accurate astrometry for that image, we tend to co-align the X-ray sources with an optical catalog, which must to some extent therefore bias the results that you get when you then try to do cross-matching. So if there's a mistake, obviously you're averaging over the whole field, so hopefully it's not bad. In the Athena case, where we're going to be confusion limited, I'm already starting to get cold shivers at the thought of the impact of this. I wonder if you have any thoughts on how serious a problem that is, and also on what would happen if you use something like N-Way, where you've got auxiliary information, to do the cross-match before you correct the astrometry, and then use the results of that to correct the astrometry. Am I just chasing my own tail here, or is there a genuine improvement to make there, do you think, especially thinking towards Athena?
Yeah, so there was this one slide where I showed the hypothesis and the cross-match, right? And that has an impact. So we are correcting our positions, or we are doing the astrometric correction based on optical or infrared catalogs. It has an impact. So typically what we do, we look at the Rayleigh distribution, and then we come up with what is expected from the random associations and so on and so forth. And then we can add systematics in the case that it is needed. Is there a way forward? Do I have an alternative to propose? Not really. I think if we had, we would have come already with a solution for that problem. So yeah, in a way we are, but it's the same with the priors if you want. I mean, we're looking for the things that we know how they behave, and then it works for the things that we know how they behave. For the unexpected, we have to explore in a different way. And that has to come up from our creativity.
I was showing the plot where with the Chandra field south, just the way in which the X-ray data were reduced, you were getting 3-4 arc-second difference in the core, even before making any calibration with optical. One group was using radio for making the precise coordinates, and the other group, I don't remember what they used, but really is going to be a huge problem also for Athena, also because, as I was mentioning, the data that we are going to use are going to be deeper and deeper, and confusion is coming also from the multi-wavelengths, not only on the X-ray part. However, what you do normally, or this is what is done in the optical, you select the bright objects and then you make the calibration. So also for Athena, I expect that you're going to have areas where you have bright stars that Gaia is going to help in identifying, and you lock your images on Gaia without any selection of the candidates in advance. So for Rosita, we were making quasar objects in WISE and Gaia for making it. I think that for Athena, you're going to have stars that can be used, and you're going to be very precise with that. And then you do the second phase.
Oh, I think I got an answer for Phil, which is it works already for XMM. The matching, registering your coordinate systems between X-rays and optical or any other waveband. So it will work better for Athena because your X-ray data will be better. You don't use your confused sources, and you've got a larger field of view with the wide field image. So it's going to be solved.
Yeah, you need isolated areas with
Yeah.
bright sources, and you lock on that.
I'm very good at worrying.
I have another question though. and I might have missed it in both the presentations using XMatch and Nway. Is it true that both approaches assume one counterpart is the X-ray source?
No,
You're assuming it can be two.
even
different
more.
ones.
We
Right.
provide for every source within 3 sigma from the X-ray position, the probability for every source to be the right counterpart. And you decide the threshold. We provide also a threshold if you like, but you can look at all of them. And there are many cases where you have 2 or 3 or even more possible counterparts with equal probability. And this is indicating that the X-ray is actually coming from 4 different sources because, as you know, eROSITA does not have the resolution of Chandra. So it's actually indicating that you should not use X overall, for example, as a prior, because the X is coming from 4 different sources.
Right, but so just to clarify, if I can, are you able to distinguish from this the case where you have 4 counterparts and you can't tell which, if any of them are the correct one, and the case where you have 4 counterparts and you're fairly confident that all of them are contributing? You can, okay, that's great.
It's a bit of like treating it as a blend. So they're all contributing up to a certain level to the X-ray emission that you might be seeing. But in some cases, if you have faint sources and even so optically faint, they could contribute with a similar probability, and then you know that it might not be associated to one specific one, but it's difficult to say that only based on geometrical or even with priors. Sometimes it's just the same probability of being the right counterpart.
So another topic that Ada mentioned this morning is about how do we, I mean, we are reaching a point, like for example, the Gaia catalog, you have billions of sources. In the future, it's going to be even worse or better. LSST, Euclid. What kind of tools, what kind of approaches we can do, normal users to do this kind of treat with this, particularly the cross-matching problem. What you mentioned, right? You have to have tools near the data. But
So yes, so there are several parts. One is like one can be tempted to build their own tool, and why not, right? And compare it with the existing ones. We have a number of tools that are stable, that are working, that are scalable. I think that's a key part of the thing, that can work for large databases already, because that was their purpose. So they were built for that. And being close to the data, I think, so sending your tool to the data, or having a tool that is already where the data is going to be more and more important. And I think that's when we talk about science platforms and things in that context, that's exactly what it is. So trusted code that can be close to the data, that can perhaps even be sent by the user, so that the user doesn't need to retrieve everything in their own. So I think that's where we are going to. Even if we were capable of downloading the whole database, I don't know any tool that could handle it. So I think that's, from my point of view, that's how I see the future.
Totally agree. No, nothing to add.
You can try to download the data, you will break the system. It happened more than one time. Yes. And so I agree with everything that was said. I just wanted to, I think everybody's aware, but I am always absurdly scared when I think about this, is that it's true. I completely agree that we should think about tools that are close to the data. Sometimes you can download a small part of the data close to you so you can do development, but once it's ready, you should go close to the data. But this also means that the tools that we are using, the way we are coding right now, is not gonna work in this very big data. So this should be specific ways of coding that should work with distributed computing and some other names that I don't know of. And this means that everyone will need to go through a very steep learning curve in order to make these things usable. I don't know how to solve the problem. It's just something that scares me a lot.
Yeah, and I think that there is another aspect on that is that I mean, this costs money. I mean very well. Giving these tools to the user means having proper system maintenance. You are not serving anymore to 10, 5 people in your institute. You are serving me thousands. So, are we prepared for that? Yeah.
Well, yes and no. So I wish that we all had a very stable system in which we were working on, and that it would be a perfect environment so that tools can always be maintained and developed. So that's the wish. Yeah. Now, making that happen, go to agencies and claim for that. Keep on doing that. I don't see anything else that we can actually do. So I mean, here, I don't think I'm the only one that is leading with that issue. It's not just a problem of tools, it's a problem of repositories, it's a problem of archives and data production. It's touching everything. So if you make a tool that you plan for it to be there for a long time, keep the people close that can maintain it.
Jean Ballet. I have a question about extended sources. Are your association codes readily applicable to extended sources, either one way, for example, associating X-ray point sources with optical galaxies, or clusters, X-ray clusters with optical galaxies that as point-like, or two ways?
So for eROSITA, what we are doing is two different approaches. For the extended sources, we look for clusters, and there you have the identification of all the optical sources that are within R500, a certain large size of the area around an X-ray source. You look for the red sequence and you determine all the sources that have more or less the same redshift using templates, and then you look at the incidence of the sources in the field around, and then a probability is assigned to an overdensity to be the one associated to the X-ray sources, and it gives also the number of members that are believed to be part of that system. And that is for the extended X-ray sources. And then we do independently now, just because of what we found in IFEDS, we pretend that every X-ray source may also be a cluster. So we do exactly the same analysis, searching for overdensity using red sequence technique. And it's the people that work on cluster that do that. And at the same time, I do N-way, pretending that the X-ray is actually coming from a single source. And then we compare the results. And what we are finding is essentially 4 different classes of objects. You have the case where the searching for clusters is absolutely certain that there is a cluster there. And N-way tells, I give you a counterpart, but is not behaving as I would expect. And then you look at the sources, indeed there is a member of the cluster. So this is a secure cluster. You have cases where the people hunting for clustering the point sources are very secure that there is a cluster, but at the same time, I am secure that there is an AGN. And then there you have 2 possibilities. When once is the AGN has the same redshift as the cluster, meaning the AGN is member of the cluster and the X-ray is coming from the cluster and from the AGN. Or you have the case where the AGN is a completely different redshift from the cluster, and then you have a superposition of solution, and again, the X-ray flux is coming from a faraway AGN or a star and the cluster. So all this is described in our catalogs, and there are classes that explain all these possible combinations, but it's done independently, making two different assumptions.
So to come back to the first part of my question, you never try to correlate X-ray sources with optical galaxies, for example, that nearby galaxies.
This is we do exactly all the time. I am not sure to understand your question then. So we take,
Well, just because an optical galaxy is not a point source, that's what I was.
you're meaning for in terms of very nearby galaxies.
well, not
Sorry, extended
necessarily
source in
so nearby.
that is a completely different group, sorry. That's what I was showing in this last slide, where you cannot search for counterpart, combining areas where you have a field sources and areas where you have a very bright nearby galaxies, because then the X-ray emission can come from the stars, ULX, from that galaxy, or the black hole of that very nearby galaxy. So those areas need to be treated separately, because really statistically, there is a lot of confusion, because the optical catalogs that you have do not count one object for these large galaxies, but all the flux is broken in many thousand objects. So statistically, making an association doesn't make any sense. So you really need to split your sample in areas where there is a bright nearby object and areas where you have the field. So it is a very distinct work. It doesn't work if you put everything together.
So there is no catalog of optical galaxies describing galaxies as a whole by just, I don't know, some kind of
So you have
elliptical.
two catalogs. There is the ECATE catalog and there is the SGA catalog. So these are catalogs of many 100,000 very nearby galaxies with few arc minutes diameter. And there you have the objects and the total flux. And you can use, it is what I'm trying to say, you have to correlate the X-ray with those catalogs to find the right counterpart. But it still doesn't tell you whether the X-ray is coming from the core of the galaxy or a ULX, because that is not part of the catalog where you have the flux of the galaxy itself.
Final question for we can end. It's about, I mean, obviously all these tools, you have to do it because you have different resolutions in the catalogs. And but what happens in the extreme cases, like for example, trying to correlate Fermi sources with Gaia sources? I guess that things get extremely complicated.
If you approach it statistically, you can still do it.
Yeah.
So there is exactly as you do X-ray to optical, you can do Fermi with Gaia. You take into account the uncertainties, you take into account all the possible source of problem, and you have a probability of the counterparts being the right one, and many other that are not, but it's really a statistical approach.
Mm-hmm.
What I would like to make clear is that if you switch the primary and the secondary catalog, you are getting different results, and it has to be clear, and this is not clear to everyone. If you do Fermi to Gaia, you have a different results than Gaia to Fermi, because the dominant is the positional error of the primary catalog that allows you to search how far you can go to search for a counterpart. So it can be done, but you need to use your brain to understand which question you are asking, which answer you want to get.
Mm-hmm.
Okay, so you can choose a primary catalog, but you can do also a symmetric approach where it's instead of being the 3 sigma of your primary, is the combined error of the catalogs. And then you would be looking a little bit further.
Yeah, that would
Yeah. So then it would, then the results are expected to be symmetric.
I think that's one of the main differences between XMatch and N-Way, that XMatch doesn't assume a primary. They treat every catalog that you put there as the same.
Exactly. Yeah.
For us, there is
And in N-Way, you have a private way.
has,
Mm.
so it's interesting actually
Mm.
make this experiment. We never.
No, we didn't do it. Yeah.
It'd be
we
nice
should,
to make a comparison.
Yes.
Okay.
And yeah, otherwise, I mean, statistically, we will get the results. I mean, we can go even to more extreme cases than Fermi, where
Gravitational
the
wave.
areas are weirdly distributed, or the detection probability of a source.
Mhm.
So yeah.
Okay, so if nobody else have any questions, comments, I think we can finish for this morning. Let's thank the panel and all the speakers of this.